Imagine you're floating in water so clear it feels like you're suspended in air. Below you, a city of impossible color and chaotic life unfolds. A coral reef, visible through shallow, transparent water, is not just a pretty postcard. It is the beating heart of our planet's ocean, a metropolis more ancient and complex than any human creation. And today, we are going to dive deeper into its reality than you ever have before. We're not just skimming the surface for pretty fish. We are going to understand this ecosystem on its own terms. From the microscopic wars waged on a single polyp to the planetary rhythms that dictate its very survival. This transparency we admire is the reef's greatest vulnerability and its most profound mystery. That crystal clear water isn't just empty space, it is a carefully maintained condition, a testament to a delicate balance of chemistry, biology, and physics that has persisted for millennia. But here is the shocking hook, the truth that most casual documentaries gloss over. That iconic visibility, that postcard perfect clarity, is hanging by a thread. The very fact that we can see the reef so clearly from the surface is not a sign of its health, but often a precursor to its silence. In many parts of the world, that transparency is now the quiet clarity of a graveyard where the complex architecture remains, but the riot of life has vanished, a phenomenon known as ecological ghosting. We are living in a time where seeing a reef clearly can be a heartbreaking experience, because what we are often seeing is the memory of what was, preserved in crystal water like a museum exhibit under glass. This journey begins with the foundation of it all, the water itself. That shallow, transparent layer is a specific and miraculous zone. It's the photic zone, where sunlight penetrates with enough strength to fuel an underwater rainforest. But transparency isn't passive. It's an active achievement. The water is cleared and filtered by a hidden army of organisms. Giant clams, sea cucumbers, and countless filter-feeding species process millions of gallons of seawater, stripping it of floating particles and plankton, competing for the very nutrients that would otherwise cloud the water. A purification system built by life, for life. The clarity allows sunlight to reach the symbiotic algae, called zooxanthellae, that live inside the coral tissues. This is one of biology's greatest partnerships. The coral animal provides a protected home and compounds for photosynthesis. The algae produce sugars and oxygen, fueling up to 90% of the coral's energy needs. This is why reefs are built in the sunlit, shallow waters. This intimate marriage with the sun is their engine. But this dependence is also their Achilles heel. That very sunlight, when coupled with rising sea temperatures, becomes a toxin. When stressed, the coral expels its colorful algal partners, revealing the stark white limestone skeleton beneath a process we know as bleaching. In that transparent water, bleaching is horrifyingly visible. The reef does. He just lose color. It loses its voice, its primary food source, and begins to starve in full view. The architecture you see, the branching antlers of staghorn coral, the massive boulders of brain coral, the delicate plates and fans, is literally built from the sea. Corals are animals that turn seawater into stone. They extract calcium and carbonate ions from the water and secrete a skeleton of calcium carbonate beneath their soft bodies. Generation after generation builds upon the bones of the past, creating the complex, three-dimensional structure that becomes the city. And what a city it is. A single football field-sized section of healthy reef can house over 1,000 different species of fish, invertebrates, sponges, and algae. The nooks and crannies provide nurseries for nearly a quarter of all marine fish. The reef as structure breaks wave energy, protecting coastlines from erosion with an efficiency that dwarfs any human-engineered seawall. It, a living breakwater that has sheltered shorelines for millions of years. But this construction project is under threat from a change in the water, its very chemistry. As the ocean absorbs excess carbon dioxide from the atmosphere, the water becomes more acidic. In more acidic water, those calcium carbonate ions are harder to grab. As if the builders suddenly found their concrete turning to slurry. The process, called ocean acidification, weakens existing skeletons, and makes it energetically costly for new corals to build. So while we marvel at the ancient castles, we must understand that the future builders are being handed weaker and weaker tools. Yet, for all the global threats, the reef as immediate environment is a constant drama. That transparent water is a stage for survival strategies so bizarre they defy imagination. There is the mantis shrimp, which can throw a punch with the acceleration of a .22 caliber bullet, creating cavitation bubbles that produce light and heat underwater to stun its prey. There is the octopus, a master of disguise and problem solving, flowing across the reefscape like liquid intelligence. There are cleaner fish and shrimp that run bustling stations, picking parasites off larger fish in a delicate dance of mutual benefit. There is also warfare. Corals are not passive rocks. They are colonial animals engaged in constant territorial battles. Some send out digestive filaments to chemically dissolve their neighbors. Others grow faster to shade competitors from the precious sun. This is a landscape of fierce competition and exquisite cooperation, all happening in the silent, clear medium of water. The transparency means there are few places to hide, which has driven the evolution of incredible camouflage, speed, and armor. Every shape, every color, every behavior is a solved problem, a millions-year-old answer to the question, how do I survive, eat, and reproduce in this crowded, visible city? This brings us to the brink of a critical question. If this system is so robust, so finely tuned by eons of evolution, how could it possibly be vulnerable to us? The answer lies in the scale and speed of change. Evolution works on millennia. Our industrial impact works on decades. The reef's ancient strategies are not prepared for this new rapid assault. So, as we finish this first deep dive into the reality of the shallow, transparent reef, I want you to hold two conflicting truths in your mind. The first is the awe-inspiring complexity, resilience, and sheer brilliance of this ecosystem. The second is its profound and gathering fragility. The very water that gives it life is becoming its conduit for stress. Understanding this duality is the first step toward meaningful action. This is not just about saving pretty fish. It's about preserving the foundational biodiversity, coastal protection, and biochemical engines of our living ocean. The story of the coral reef is the story of our planet's health, written in living stone and clear water. And if you want to be part of the next chapter, the chapter of solutions, of resilience, and of hope, then you need to stay with me. Because in the next section, we will pull back the lens and see how this single visible reef is connected to everything, from the clouds above to the deep ocean trenches below, and more importantly, what is happening right now on the front lines of coral science that gives us real, tangible hope. This is a story that is still being written, and your attention is the first act of participation. So subscribe to this channel, hit the notification bell, because we are just getting to the most crucial part. The diagnosis is grim, but the prognosis is still in our hands. Let's keep going. We ended by seeing the reef as a self-contained city, but that's an illusion of that clear, shallow water. The truth is, a coral reef is not an island. It is a central node in a vast planetary network, deeply woven into systems that span the globe. The transparent surface is a permeable membrane, not a barrier. To believe the reef exists in isolation is to misunderstand it completely. Its health is dictated by forces far beyond its visible borders. Think of the water itself. Where does it come from? Ocean currents are the rivers of the sea, and they deliver the reef's essential ingredients: warmth, planktonic food, and the larvae of new life. The great conveyor belts of ocean circulation connect a reef in the Caribbean to upwellings off the coast of Africa, and a reef in the Pacific to melting ice in Antarctica. When these currents shift or slow due to climate change, and there the reef's lifelines are cut. It's like a city whose supply roads are slowly crumbling. Then look up. The weather above the water is equally crucial. The frequency and intensity of storms are changing. A severe cyclone can physically smash a reef, breaking centuries of growth into rubble in a few hours. While reefs have always recovered from natural storms, The increasing frequency leaves no time for rebuilding. It's a constant state of demolition, without a break for reconstruction. But the connection runs even deeper, literally into the land. This is perhaps the most underrated threat, visible only when we trace the water's journey. That pristine, transparent water over a reef is often fed by what happens onshore, miles away. When it rains on tropical islands or coastal areas, water runs off the land in a healthy, forested watershed. This water is filtered through soil and vegetation, reaching the sea relatively clean. But when we clear land for agriculture, development, or logging, the equation changes dramatically. Unchecked runoff carries a slurry of topsoil, fertilizers, pesticides, and waste into the ocean. This is where transparency dies. The war clouds with sediment literally smothering corals by blocking the sunlight they need. It's a slow burial. Furthermore, the fertilizer cause algal blooms. These algae, both microscopic and large, thrive on the excess nutrient, creating thick mats that outcompete corals for space and light. They turn the clear, blue water into a green, murky soup. This process, called eutrophication, is a direct, lethal export from human land use. So, a farmer applying fertilizer in the hills, or a construction crew clearing a coastal plot, can be unknowingly signing a death warrant for a reef they may never see. The reef's visibility is its report card for our entire watershed management. Now, let's inject some hard, original database perspective. You often hear, coral reefs are dying, which is true but vague. Let's get specific. Since the 1950s, we have lost approximately 50% of the world's live coral cover. The leading cause is climate change-induced mass bleaching events. The benchmark year is 1998, during a strong El Niño, which saw the first global-scale bleaching, but the pace is accelerating. The 3-year period from 2014 to 2017 was catastrophic, with the Great Barrier Reef losing nearly 50% of its shallow water corals in just those 2 years. But here's a critical, less reported data point. The loss is not uniform. Scientists are discovering what they call bright spots. These are reefs that are thriving against the odds, often in places where local human communities are actively, traditionally engaged in stewardship. A 2016 study published in Nature analyzed over 2,500 reefs worldwide and found that while climate change was the overwhelming long-term threat, local management controlling overfishing and pollution made a significant difference in a reef's ability to resist and recover from bleaching. This is not just an anecdote, it's a data-driven insight. It tells us that while we absolutely must fight global warming, we cannot abandon local action. Protecting a reef from the fertilizer runoff and the dredging today gives it a fighting chance to survive the heat waves of tomorrow. It builds ecological resilience. This brings us to the incredible hidden life of the reef that we rarely consider, the microbes. For every coral polyp or fish you see, there are billions of invisible actors. The coral holobiont, the coral animal, its zooxanthellae algae, and a unique associated community of bacteria, viruses, and fungi is a mini ecosystem. This microbiome is essential for nutrient cycling, disease prevention, and thermal tolerance. Think of it as the coral's immune system and digestive aid. New research is showing that a healthy, diverse microbiome might be a key trait of heat-resistant corals. When a coral bleaches, it's not just losing algae. Its entire microbial community is thrown into dysbiosis, a state of imbalance. Some scientists are now exploring probiotic treatments for reefs, attempting to inoculate stressed corals with beneficial bacteria to help them weather thermal stress. It's a fascinating frontier, treating an ecosystem like a patient. Furthermore, the water column itself, that transparent medium, is teeming with a soup of genetic material shed by all reef organisms, fish, mucus, coral cells, microbial plankton. This environmental DNA, or EDNA, is revolutionizing reef monitoring. Scientists can now take a simple water sample, sequence the DNA fragments within it, and get a comprehensive census of what species are present on the reef without ever seeing a single creature. This is a powerful, non-invasive tool for tracking biodiversity loss and recovery. So the narrative of the doomed reef, while grounded in terrifying truth, is incomplete. The full story includes these threads of connection and resilience. The reef is tied to the land, the sky, and the global climate. Its fate is a composite of global carbon emissions and local sewage treatment policies. And within its own biology, from the scale of the microbiome to the scale of bright spot communities, lie clues and tools for its salvation. Our role shifts from passive observers of a tragedy to potential actors in a drama of recovery. But this requires a radical upgrade in our understanding. We must see the reef not as a distant, beautiful vacation destination, but as the integrated heart of a coastal system that supports human life through fisheries, tourism, and protection. As we move forward, we will shift from diagnosis to treatment. We will explore the most cutting-edge, hands-on interventions that scientists are deploying right now, from cryogenically preserving coral sperm to creating 3D printed artificial reef structures, from assisted evolution in labs to reef-safe sunscreen policies. The path is complex, expensive, and uncertain, but it is being forged, and your understanding of these connections is the prerequisite for supporting the right solutions. If you're still with me, you're moving from a viewer to an informed advocate. Share this video with someone who thinks the reef is just a pretty screensaver. Let's change that perception together. The story continues in the next chapters where we roll up our sleeves. Welcome back to the front lines. We've diagnosed the problem and understood the connections. Now we enter the most dynamic phase, the global effort to intervene. This isn't just conservation, it's active restoration, a field blending marine biology, robotics, architecture, and genetics. The goal is no longer simply to protect what remains, though that is vital, but to actively heal and regrow. Imagine not just putting up a fence around a crumbling cathedral, but teaching the stones to regenerate and training new masons. The first and most fundamental strategy is the creation of marine protected areas, or MPAs. These are essentially national parks for the ocean, where damaging activities like fishing, dredging, or anchoring are restricted or banned. The data is clear, well enforced. No-take MPAs see fish biomass increase by over 600% on average, and the fish within are larger, older, and produce exponentially more offspring. These offspring then spill over into adjacent fishing grounds, boosting local catches. A healthy, intact fish population is critical for reefs. Parrotfish, for example, are constant grazers on algae. Without them, algae can overgrow and kill coral, so MPAs create the safe space for natural processes to rebound. But they are not a silver bullet. A MPA cannot stop a global heat wave. The water within its boundaries will still warm. So, protection is the foundation, but on its own, it is insufficient against the climate threat. This is where human-assisted restoration comes in. The most widespread technique is coral gardening. Think of it as underwater agriculture. Divers collect small fragments of healthy, often resilient corals from the wild. These fragments are then attached to underwater nursery simple structures like PVC trees or mesh tables, where they are grown in ideal conditions, safe from predators and competitors. In 1 to 2 years, a fingernail-sized fragment can grow to the size of a soccer ball. Once they reach a robust size, these nursery-raised corals are outplanted or transplanted onto damaged sections of the reef. It's labor-intensive, scuba-dependent work, but it works. Organizations worldwide have outplanted hundreds of thousands of corals. However, the scale of the problem is daunting. The Great Barrier Reef is the size of Italy. Hand-planting corals is like trying to reforest a continent by planting one tree at a time. This scale challenge is driving incredible innovation. Enter robotics and mass production. Universities and companies are now developing underwater drones called autonomous underwater vehicles, AUVs, equipped with special arms and computer vision. These AUVs can map a degraded reef, identify ideal outplanting sites, and then mechanically attach coral fragments or pre-seeded plugs at a rate hundreds of times faster than a human diver. Some projects are even using robotic reef printers. Large, boat-based 3D. Printers use sustainable materials like calcium carbonate-based ceramics or even recycled glass to print intricate artificial reef structures. These are not bland concrete blocks. They're designed with complex geometries that mimic natural coral forms, optimized to encourage larval settlement and provide shelter for fish. They are deployed to provide instant habitat complexity on barren sand or rubble, creating a foundation for natural recovery. But what if the corals we are growing and planting are themselves vulnerable to the warmer oceans of the future? This question has launched the field of assisted evolution. Scientists are not genetically engineering supercorals in the classic sci-fi sense, but they are actively guiding and accelerating natural selection. In labs, they subject coral larvae and fragments to gradually increasing levels of heat or acidity, a process called stress hardening. The individuals that survive are presumed to have greater inherent tolerance. These super survivors are then bred together, their offspring inheriting and concentrating these resilient traits. Another approach leverages the natural variation found across a reef. Corals living in naturally warmer microhabitats, like in a shallow lagoon that becomes a hot bath low tide, may already possess heat-tolerant strains of zooxanthellae. These corals can be cross-fragmented with corals from a cooler area, creating new combinations. There also work on manipulating the coral's microbiome, as we discussed, to include more heat-resistant bacteria. The most futuristic and perhaps most crucial work is coral cryopreservation. Biobanks, like the frozen zoo for corals, are being established. Scientists collect and flash freeze coral sperm, eggs, and even tiny larvae in liquid nitrogen at minus 196 degrees Celsius. This creates a living library of genetic diversity and insurance policy against extinction. If a species is wiped out in the wild, its genetic blueprint could be preserved for future restoration if ocean conditions stabilize. All these technological interventions, however, risk being just expensive band-aids if the root causes are not addressed. This is where policy, economics, and individual action create the necessary ecosystem for these solutions to thrive. On the policy front, the most direct link is reducing land-based pollution. Legislation that mandates improved wastewater treatment, regulates agricultural runoff, and protect coastal mangroves and seagrass beds, which are fantastic natural filters, is essential. Then there is the carbon equation. Every nation's climate policy directly impacts reef futures, but there are also targeted financial tools. Blue bonds are debt restructuring instruments where a country commits to protecting marine areas in exchange for favorable loan terms. Reef insurance is a real product. In places like Quintana Roo, Mexico, local hotels and governments pay an insurance premium. If a hurricane of a certain strength hits, the policy pays out immediately, funding rapid response. Reef repair teams to clear debris and reattach corals before they are permanently lost. This turns post-disaster recovery from a years-long fundraising effort into a days-long operational response. Finally, there is the power of consumer choice. The demand for reef-safe sunscreen, free of oxybenzone and octinoxate, which are proven to harm coral larvae, has forced entire industries to reformulate. Tourism operators who adopt eco-certifications and educate their guests create a market for sustainable interaction. So we stand at a crossroads of despair and ingenuity. The scale of loss is historic, but the toolbox for response is more sophisticated than ever before. We are no longer mere observers. We are becoming gardeners, engineers, and archivists of the reef. The path forward is a dual one: relentless global action to decarbonize our economy and stabilize the climate, combined with aggressive, smart local intervention to build resilience and buy time. One cannot succeed without the other. This isn't about returning the reef to some mythical, pre-human state. That is likely impossible. It is about guiding it through a bottleneck of human-made change, helping it adapt so it can continue to function as the vital ecosystem it has been for millennia. The work is arduous, often happening out of sight, funded by grit and grants, but it is work fueled by a profound understanding that losing these ecosystems is not an option, not for the ocean, and not for us. In our next and penultimate section, we will make this connection personal and planetary. We will look beyond the reef's beauty and explore the indispensable life-supporting services it provides to humanity, services that have an enormous, calculable economic value, and whose loss would trigger a cascade of human crises. This is why the fight for the reef is, inescapably, a fight for our own future. Stay with me. Hit the like button if you're learning just how deep this issue goes. It helps this channel reach more people who need to see this. We're building a community of the informed, and that is the first step toward becoming a community of the effective. We've explored the reef's biology, its interconnected threats, and the heroic efforts to save it. Now we must answer the most pragmatic, and for many the most compelling question: why does this matter to me? If you live far from any ocean, what difference does a patch of colorful animals in clear water make to your life, your wallet, your safety? The answer is more than you can possibly imagine. A coral reef is not a luxury. It is a critical piece of planetary infrastructure. Its value is often hidden, but it is immense, calculable, and directly tied to human well-being on a global scale. Let's start with the most immediate service: coastal protection. A healthy, structurally complex reef acts as a natural, live-in breakwater. It dissipates up to 97% of wave energy before it hits the shore. This isn't just about pretty beaches. It's about preventing erosion, safeguarding coastal communities, and protecting vital infrastructure like roads, power plants, and homes. The economic value of this service is staggering. In the United States alone, coral reefs provide flood protection benefits to over 18,000 people and $1.8 billion in avoided damages annually, according to the U.S. Geological Survey and NOAA. In developing nations with long coastlines like Indonesia or the Philippines, reefs are the first and most cost-effective line of defense against tropical storms and tsunamis. Without them, the cost of building artificial seawalls would be astronomical and often economically impossible for small island nations. The loss of a reef translates directly into increased vulnerability, displacement of people, and massive reconstruction costs after every storm. Next, let's talk about food. Coral reefs are often called the rainforests of the sea for their biodiversity, but they are more accurately described as the supermarkets of the sea for hundreds of millions of people. An estimated 500 million to 1 billion people worldwide depend on reef fisheries for their primary source of protein and livelihood. These are not industrial trawlers. These are small-scale, artisanal fishers who feed their families and local communities. A healthy reef supports a higher biomass and diversity of fish than any other marine habitat. The complex structure provides nurseries for countless species, including many that spend their adult lives in the open ocean. This means the health of the reef directly impacts the health of offshore fisheries. When a reef dies and its structure collapses, the fish community transforms, biodiversity plummets, and what remains are often smaller, less commercially valuable species. The economic ripple effect is devastating. Lost income for fishers, increased prices for consumers, and a deepening of food insecurity in regions already on the edge. It's a direct link from ocean chemistry to dinner plates in coastal villages and global seafood markets. The third pillar is medicine. The coral reef is the world's most promising and least explored pharmacy. The intense competition for space and survival in that crowded, transparent city has led to an evolutionary arms race of chemical warfare. Organisms produce complex compounds to deter predators, fight infections, and prevent overgrowth. These compounds are gold mines for biomedical research. Already, drugs derived from reef organisms are used to treat some of humanity's most dire diseases. Compounds from sea sponges are the basis for the antiviral drug AZT used to fight HIV/AIDS. A molecule from a Caribbean sea squirt is used in chemotherapy for leukemia and ovarian cancer. Coral skeletons, due to their porous, three-dimensional structure, are being used as templates for bone grafts in humans as they are biocompatible and encourage new bone growth. Scientists estimate that less than 1% of the potential pharmaceutical compounds on reefs have been discovered. We are literally burning the library of future cures before we've even read the titles of the books. Every species that goes extinct takes with it a unique chemical blueprint that could have held the key to treating cancer, Alzheimer's, or antibiotic-resistant bacteria. The economic value of this bioprospecting potential is incalculable, but undoubtedly in the trillions of dollars. Then there is the direct economic engine of tourism and recreation. For many nations, a living reef is their primary economic asset. Think of the Great Barrier Reef in Australia, the Mesoamerican Reef in the Caribbean, or the reefs of the Maldives and Seychelles. The global value of reef tourism is estimated at $36 billion per year. This supports not just dive shops and tour boats, but entire ecosystems of hotels, restaurants, transportation, and souvenir industries. It is the foundation of national economies. When a reef bleaches and dies, the tourism model collapses. Tourists do not pay to see white, dead coral. They may come once, out of morbid curiosity, but they will not return, and they will not recommend it. The loss is multidimensional. Dive guides lose jobs, hotel occupancy plummets, and regional economies contract. This isn't a distant future scenario, it's happening now. Following major bleaching events, tourism regions see significant cancellations and have to invest heavily in marketing to rebrand themselves, often shifting focus away from the reef they can no longer reliably showcase. Finally, reefs play a crucial, if subtle, role in the global carbon and nitrogen cycles. While they are not the lungs of the planet that's primarily phytoplankton and forests, they are significant carbon processors. The process of calcification building those limestone skeletons actually releases CO2, making them a minor source. However, this is more than offset by the enormous amount of carbon stored in the sediments behind reefs and in associated ecosystems like mangroves and seagrass beds, which reefs help protect. More importantly, they are master recyclers of nutrients in nutrient-poor tropical waters. The tight, efficient cycling of nitrogen and phosphorus within the reef system is a model of sustainability. In a world facing climate change and resource scarcity, understanding and preserving these efficient, circular systems is knowledge we cannot afford to lose. So when we talk about saving coral reefs, we are not talking about an environmental niche issue. We are talking about global food security, climate resilience, medical breakthroughs, and sustainable economic development. The reef's value is its functionality. Its beauty is merely the visible manifestation of that profound utility. Losing it would be an economic and humanitarian catastrophe of epic proportions, destabilizing nations and crippling our collective future. This understanding must be the bedrock of our will to act. As we move into our final section, we will synthesize all of this, the wonder, the threat, the science, and the stakes into a clear, actionable vision for what comes next. This isn't where the story ends. It's where your part in it truly begins. If this connection between that clear, shallow water and your own life resonates with you, share this video. Spark this conversation. The reef needs translators, people who can explain why it matters in the boardroom, the voting booth, and the classroom. Be one of them. We have journeyed from the microscopic symbiosis within a coral polyp to the global economic systems dependent on the reef's health. We've seen the terrifying scale of the threat and the inspiring breadth of the human response. Now, we arrive at the synthesis, the call to perspective and action. The narrative of the coral reef visible through shallow, transparent water is the ultimate parable for the Anthropocene, the age of human dominance on Earth. It encapsulates our capacity for awe-inspired observation or unintended destruction, and our potential for intelligent stewardship. That clear water is a mirror, and what it reflects back at us is our own choices. Do we see a resource to be exploited until it's gone, a museum piece to be gawked at, or a partner in a shared biosphere to be understood and protected? The answer to that question will define the 21st century for our oceans. The reef teaches us about interconnectivity in the most visceral way. There's no way. The carbon from our tailpipes and smokestacks dissolves into the ocean, changing its chemistry. The fertilizer from our farms runs into the sea, clouding its waters. Our demand for cheap seafood drives destructive fishing practices. But the inverse is also true. Our choices for renewable energy, sustainable agriculture, and responsible consumption directly benefit that distant, visible city under the waves. The line of responsibility is unbroken. So what does effective action look like? It must be multi-layered from the planetary to the personal. At the global level, it is unequivocally about reducing greenhouse gas emissions. Every fraction of a degree of warming avoided is a breath of life for reefs. Supporting international agreements like the Paris Accord, advocating for national policies that rapidly transition to clean energy, and holding corporations accountable for their carbon footprints are non-negotiable. This is the long game, the ultimate cure. But while we fight the decades-long battle, we must also engage in the local and regional triage. Supporting the creation and strong enforcement of marine protected areas is critical. Donating to or volunteering with organizations that do hands-on restoration like the Coral Restoration Foundation, Secure International, or the Great Barrier Reef Foundation puts money and muscle directly into the water. These groups are the gardeners, and they need tools, boats, and manpower. Advocate for policies that reduce land-based pollution. Support sustainable seafood choices by using guides from the Marine Stewardship Council or Seafood Watch. Choose reef-safe sunscreen and encourage your hotels and tour operators to do the same. When you travel to a reef, be a responsible tourist. Choose operators with eco-certifications. Do not touch or stand on the coral and follow all guidelines. Be a witness, not a stressor. But perhaps the most powerful thing you can do is to use your voice and your curiosity. We are drowning in information but starved for wisdom. Become a source of that wisdom. Share documentaries, articles, and videos like this one that move beyond the surface level beauty to explain the deeper truth. Talk about the reef not just as a place that's dying, but as a place we are actively working to understand and rebuild. Frame it in terms of its value, coastal defense, food security, medical discovery. This shifts the conversation from guilt to purpose, from loss to investment. Support journalism and science communication that covers these issues in depth. Scientists are not just doing experiments, they are building arcs. Their stories need to be told. Furthermore, encourage the integration of this knowledge into education. Children who understand the connection between their actions and a coral reef growing up to be voters, consumers, and leaders who make different choices. I want to leave you with a final original database concept, the idea of reef time versus human time. Reefs operate on a time scale that is almost incomprehensible to us. The Great Barrier Reef began forming roughly 20 million years ago. The massive corals you see today may be hundreds of years old. Their growth is measured in centimeters per year. Their reproduction is a synchronized, annual event tied to the moon. Human industrial time, by contrast, is blisteringly fast. We have altered the planet's atmosphere and oceans in mere decades. This mismatch is at the core of the crisis. Our rapid actions have created a slow-motion disaster for them. But this also gives us a strategic insight. If we can quickly change our systems, our energy, our agriculture, our economics, we can create a stable environment within which the reef's slow, ancient processes of growth, adaptation, and recovery can once again function. We have to align our tempo with our need for stability. We must be the rapid responders who create the conditions for slow healing. This is our unique responsibility as the planet's most powerful and now most conscious species. The image we started with, a coral reef visible through shallow, transparent water, will forever be changed. It can no longer be just an icon of paradise. It must become an icon of complexity, of vulnerability, and of resilience. It is a living report card on our relationship with the natural world. The future chapters of this story are not yet written. They will be written by the scientists in their labs and on their dive boats, by the policymakers in conference rooms, by the coastal communities who depend on the reef, and by you, by where you choose to focus your attention, spend your money, and direct your voice. This is not a passive viewing experience. This has been a briefing. You are now informed. The shock of the bleaching events, the engagement of the restoration stores, the undeniable data of economic value, these are your tools. So here's your final, most important call to action. Do not let this end here. Let this be the beginning of your engagement. Subscribe to this channel because we will continue to track these stories of ocean solutions. Hit the notification bell so you don't miss the next deep dive. Like this video to help the algorithm. Show it to others who need to see it. Share it with at least one person today. Start a conversation. And most importantly, choose one action from the many we discussed and commit to it. Whether it's switching your sunscreen, donating to a restoration group, writing a letter to a representative about climate policy, or simply deciding to learn more. The reef's survival depends on a vast, interconnected network of life. Its recovery depends on a vast, interconnected network of people who decided to care and to act. You are now a node in that network. The water is clear. The view is unmistakable. The choice is yours. Let's get to work.